Hello, welcome to College Algebra section R4. We're covering solving polynomial equations by factoring in this particular one, and we will start with a little bit of factoring, just a general polynomial. So hopefully you all remember how to factor, because this is something that I don't plan on spending any time on. There is practice that we're going to be going through in ALEX, and you'll be practicing in class. But this is something that you should already know, and we're just refreshing your memory. So you can follow this flow chart to help you factor if possible. The first thing you always do is look for a greatest common factor. I'm going to put up a factoring problem here, and then I'll go through this flow chart with the factoring problem. Okay, I put a problem at the top of the screen. This is going to cover a number of the different factoring types here, so it's pretty extensive. 2x cubed minus 10x squared minus 8x plus 40. So the first step whenever we factor is to look for a greatest common factor in every term. And there is one. Since each of these terms are even, I know that 2 must be a common factor. Now, it's not necessarily the greatest common factor, but it's a good place to start. So I'm going to factor a 2 out. So that means divide each term by 2. So 2x cubed divided by 2 is x cubed. 10x squared divided by 2 is 5x squared. 8x divided by 2 is 4x. And 40 divided by 2 is 20. So that's step 1. Now I'm going to basically ignore the 2. I need to make sure it's in my final answer, but I'm going to look inside this parentheses, and I'm going to start at the top of the flowchart again. Can I factor out a greatest common factor? Well, there's no other factors in common with every single term, so there are no more common factors. Next, I'm going to count the number of terms inside this parentheses. There's 1, 2, 3, 4 terms, so I'm going to do the 4-term process, which right now the only method we have is factor by grouping. So you can factor by grouping by using the box if you want, or by parentheses. To factor by grouping using the box, I can show you the parentheses in class as well. There's always multiple ways to do these problems. I put each of the terms inside a box, and I start at the top left with the first term. So I have x cubed. I keep the sign with the thing after it, so it's negative 5x squared, negative 4x, and positive 20. And then I factor. I look for a greatest common factor in each row and each column of the box. So in the first column, I have x in common. In the second one, I have a 5 in common. In the first row, I have x squared in common. And in the second row, I have 4. And then we can write this as 2 parentheses. So the one on the top would be our first parentheses. So that would be x and a positive 5. And then the second one is x squared and a positive 4. Now the problem with this is that I have minus minus up here, and I have plus plus down there. And so right away I know I have a problem with my signs, because there's no way I will get negatives if everything is positive. So what does that mean? Since this last term is a positive 20, the only way to get a positive 20 when I'm multiplying is to multiply a negative times a negative. So this is minus 5 and minus 4. It's important to always go back and check your answer to make sure you didn't make a mistake with the signs. So I bring the 2 back down with me, and I say, okay, this looks like maybe I'm done, but I'm not sure. I need to look inside each parentheses again and start at the top. So if I look at x minus 5, there's nothing I can factor there. This is linear. But if I look over here at x squared minus 4, maybe I can factor that. So I start here, no greatest common factor, count the number of terms. Let me change my pointer color to blue. So now I count, and I have 2 terms. So now I determine if my 2 terms follow one of these patterns. Is it something squared minus something else squared? Yes, this is. This is x squared minus 2 squared. So it falls into this pattern where a is x and b is 2. So all I do is apply this formula. So x squared minus 4 can be factored into x plus 2, x minus 2. So this finally, tacking back on everything I already did, ends up being 2 times x minus 5 times x plus 2 times x minus 2. Okay, so that is a very, very quick review of some factoring. Now let's look at it as it applies to a quadratic. Now, what's the difference between these quadratic trinomial, a quadratic equation, and a polynomial equation, quadratic in form? So a quadratic trinomial is, in standard form, is ax squared plus bx plus c. A quadratic equation means there's an equal sign. So this is ax squared plus bx plus c equals 0. Okay, so that's the difference between a trinomial and an equation, this equal part. But then what about a polynomial equation, quadratic in form? Well, that would be when I have something where it looks like I have something squared, like it could be something like x minus 1 squared plus b times x minus 1 plus c equals 0. So this is of the same form where the thing squared is a binomial and the thing to the first power is the same binomial, just raised to the first power. So this is a quadratic in form and can be solved by simply replacing the x minus 1 with u, because when we do that, it becomes a u squared plus bu plus c equals 0. So we can solve this just like it's a quadratic. So that's a polynomial equation, quadratic in form. You will be solving all of those types of problems in this section in ALEKS. So do you remember how to solve something like this? You should pause this and try it on your own first. But we're going to solve by factoring right now. So I need to figure out if I can factor x squared minus 3x minus 10, which I can. I can factor that on the fly. I need two things that multiply to give me negative 10 and add to give me negative 3. And that would be minus 5 and plus 2. So I would factor it like that. So now that I have two things that multiply to give me 0, I have a binomial times a binomial equal to 0. I can use the zero product property. And so what that says is if I have two things that multiply that equal 0, one or both of them must be 0, right? If I have 5 times what equals 0? It has to be 5 times 0 equals 0. So in the same way, we solve this problem. So I set x minus 5 equal to 0, and I solve that. I get x equals 5, and I set x plus 2 equal to 0, and I solve that. I get x equals negative 2. So in that way, I get two answers, and if I were to write that in set notation using the roster method, that would just be writing the two numbers inside the curly brackets. And that says my answer is negative 2 and 5. I have two answers. The number of answers, we'll talk about this more when we talk about solving polynomials, which I believe is in chapter 4. The number of answers always matches the exponent. So if it's raised to the second power, you're always going to get two answers. There's all sorts of caveats that go along with that we'll talk about later. So we also need to solve something that looks like this. So this is a polynomial that's quadratic in form. And in order to factor it, we first need to get everything on one side. So it's in the form au squared plus bu plus c equals 0. So we need to move the 10x squared to the other side, and we need to put it before the 9. So we get x to the 4th, my pen's not working again, x to the 4th minus 10 x squared x, wow, it's really not working. X squared plus 9 equals 0. Okay, so I need something raised to the second power and something raised to the first power. So that means my u, if I were to do u substitution, I would say u is equal to x squared. So replacing x squared with u would give me minus 10u plus 9 equals 0. And then if I take x squared and I square it, I get x to the fourth. So this must be u squared. And then I factor that. So u squared minus 10u plus 9 factors into u, let's see, two things that multiply to give me 9 and add to give me negative 10 would be minus 9 and minus 1. So I get u minus 9 equals 0. So that means u has to equal 9. And u minus 1 equals 0. So that means u has to equal 1. Except I don't care what u is. I care what x is. So I need to replace u with x squared. So I get x squared equals 9. And x squared equals 1. And then I have to solve this. How do I solve that? Do you remember? I take the square root of both sides. So I take the square root of x squared and the square root of 9. And I take the square root of x squared and the square root of 1. And so I get x equals the square root of 9 could be positive 3 or it could be negative 3. The square root of 1 could be positive 1 or it could be negative 1. Now notice here I have 4 answers, and that makes sense because this is raised to the fourth power. Okay, in class we worked on completing the square. We did a discovery activity and we figured out in general that if I have x squared plus bx, if I figure out what would make this a perfect square trinomial, I could factor it in this form. And the perfect square trinomial is when I take half of b and I square it. And then when I factor it, it becomes x plus b over 2 squared. So we're going to use it in section 1.1 on circles. But for this example, we will solve a quadratic equation with it. So if I take x squared minus 4x equals 5, we could try and factor this problem by subtracting and putting the 5 on one side. But instead of factoring it, we're going to complete the square. So that means I want to turn x squared minus 4x into a perfect square trinomial by adding something. And as long as I add that same thing to the other side of the equation, then I keep my equation balanced. As long as I keep my equation balanced, I can do anything I want. So in this problem, b is equal to 4. Don't worry about the negative because when you square it, it would be positive anyway. So this needs to be b over 2 squared. So b over 2 is 2, and so this ends up just being 4 again. Possibly not the best example because this is 2 squared right here. So since I added 4 to the left-hand side, I need to add 4 to the right-hand side to keep the equation balanced. So what happens is the left-hand side, I get x squared minus 4x plus 4, and I need to factor that. I factor that trinomial, and it's x minus 2 quantity squared. Why is it minus? Because this is a minus sign. It's always going to match the sign here. Let me draw a little arrow. This always matches right there. And then 5 plus 4 is 9. Okay, just like on the previous slide, how do I solve this for x? I have something squared equals 9. I take the square root of both sides. So I take the square root of x minus 2 squared. The square root and the square cancel each other out. And then I take the square root of 9, which could be positive 3, or it could be negative 3. Again, I don't care what x minus 2 is, though. I want to know what x is. So I get x, I get two answers. X equals positive 3 plus 2, or I get the negative, x equals negative 3 plus 2. So that means that x equals 5 or x equals -1. And just to double check it, if I had decided instead that I was going to factor this problem, I would have moved the 5 to the other side first, and then if I'd factored it, I would have gotten x minus 5 times x plus 1 equals 0. And if I'd have solved that, x minus 5 equal to 0 would give me x equals positive 5, and x plus 1 equals 0 would have given me x equals -1. So this is my answer. If I were to write it using the standard set notation, where I set x as a rule, you would just put the curly brackets and the x such that on the outside. So the solution is a set of all x where x is 5 or -1. Alright, so that's it for section R4, and we will do practice on these two sections in class. Have a great day.